This section is going to concentrate on factoring trinomials when that first term in the trinomial is just 1x squared. So an understood 1, just x squared with no number in front of it. Section 6.3 is going to focus on when we have a number in front of it that can't just be factored out. We will see some problems late in this section where there's a number that can be factored out of everything, but in the end, really this process for factoring trinomials requires you to have just positive x squared as the leading coefficient. So we're going to learn to factor trinomials of this form, x squared plus bx plus c. We're going to learn how to do it after factoring out a greatest common factor. And then finally we're going to learn using a grouping method, similar to what we did at the end of 6.1. So we've previously learned how to multiply binomials, where we said if we have x plus 2 times x plus 3, there's actually 4 multiplications that need to occur. X times x times 3, 2 times x, and 2 times 3. X times x gives me x squared. X times 3 gives me 3x. 2 times x gives me 2x. 2 times 3 gives me 6. When I combine them, these two middle terms combine to give me 5x. The x squared and the 6 stay as they are. So I started out with x plus 2 times x plus 3. I ended up, once I expanded it, with x squared plus 5x plus 6. To factor the trinomial x squared plus 5x plus 6, we're going to reverse multiplication and try and get back to this factored form. So it would be the product of two binomials in the end that we're really looking for. So multiplication goes in this direction, factoring goes in this direction. We're considering for section 6.2 when the leading coefficient is 1, so in other words when this a isn't really there because it's an understood 1, like it is here. So to develop a method, we're going to look at things as a first term, a middle term, and a last term. So the first term is whatever's in front of the x squared. Again, we're going to be focused on things where nothing's there, where it's just an understood 1x squared. Middle term where we're focused on what's in front of the x, in this case it would have been a 9. And the last term where we're focused on the number, including the sign of what has no power of x with it. So we can see that the first term, x squared, is the product of x and x. The last term, 20, is the product of 4 and 5. And the coefficient in the middle is the sum of 4 and 5. We can use these facts to factor this trinomial. So if we have x squared plus 5x plus 6, we assume it's the product of two binomials. Where we're going to start is because it starts with just x squared, it must be x in first position, x in second position. So normally when I teach this, I say start by making your two parentheses, put x in each of the first two positions. After you have your x's in, we need to worry about what comes here including a sign, what comes here including a sign. The way that we're going to get there is we're going to start at the last term, 6. Really a positive 6. And we're going to say, what are the different ways that I could multiply two numbers in order to create a positive 6? So we could do 1 times 6 to get 6, or we could do 2 times 3 to get 6. Once we figured out the different ways we can multiply to 6, then we have to look at the factors and see what happens when either we add or subtract them. The reason that we're going to add them is because of this plus sign here in front of the final term. If this was a minus sign, we'd subtract them. So when I sum 1 plus 6, I get 7, but I want it to add to the middle term 5. 7 doesn't equal 5, so these aren't the factors that I'm looking for. When I try it with 2 and 3, 2 plus 3 does equal 5, so 2 and 3 are the factors that I'm looking for. That's why a positive 2 and a positive 3 can go in these second two positions. So we started out with two parentheses, x and x. We then look at the last term, think of the different ways we can multiply to that term, and consider whether we're either doing a sum or difference of those two terms based on the last sign in the trinomial. So this sign being a plus told me we were going to add them. 2 plus 3 gives me 5, which is the middle term. 2 times 3 gives me 6, which is the last term. We can show this done out that we get back to where we started if we multiply out these two binomials. So, the following sign patterns can be helpful. Factor x squared plus bx plus c. If c is positive, the integers have the same sign, and we're really going to add them when we look at the two factors. If c is negative, the integers have opposite signs, and we're really going to subtract them when we look at the two factors. When factoring out the trinomials of the form ax squared plus bx plus c, where a is -1, begin by factoring out -1. All that's saying is, if I have not just a positive 1 here, I want to divide by the negative if it says -x squared. That way I'll get to a positive x squared. I'll just put parentheses around my answer with a -1 out front. But really, to continue to use the methods we're talking about here, it needs to be a positive 1x squared that's leading. So you may have to factor something out before you can get to that positive 1x squared. Just like we did in 6.1, we may need to look for a common factor among the three parts of the trinomial that's being listed. For instance, if we have 2x to the fourth plus 26x to the third plus 80x to the second. In this case, 2 is a common factor of each of these. So 2 divides evenly into 2, divides evenly into 26, divides evenly into 80. I could have created prime factorizations for each of 26 and 80, but really, if I just start with the prime factorization of 2, it's just 1 times 2. It's the only way to get there. So to see out what all the other factors are of these two really isn't necessary, because I just need to check, does 2 go into them? If I get prime factors beyond 2, I know it's not going to work because my very first term just has 2 as its possible multiples. So once I figure out that 2 is the biggest thing that goes into all three of these, I look for the smallest power of x. The smallest power of x I see is x squared. So what I'm going to want to take out is the coefficient 2 and the variable x squared. We'll factor out the GCF, 2x squared first, then we can factor the trinomial that's left. When we factor out the 2x squared, we divide each of these terms by 2x squared. 2x to the fourth divided by 2x squared, so the 2's go away. 4 minus 2 just gives me x squared. 26x to the third divided by 2x squared, 26 divided by 2 gives me 13. X to the third divided by x squared is x to the 3 minus 2. That's why it's just the single power of x with the 13. 80x squared divided by 2x squared, so the x squareds go away. 80 divided by 2 is 40. So now we have this common factor that's out front, parentheses, what's left over, and what's left over is a trinomial that we're able to factor. We would start out by doing parentheses, parentheses, x and x. Then we'd look at this sign to say, all right, positive tells me that I'm going to be adding two factors of 40 to get 13. I would write out the different ways to multiply the 40. So it could be 1 times 40, but when I add them I get 41. Could be 2 times 20, but when I add them I get 22. It could be 10 times 4, but when I add them I get 14. Or it could be 8 times 5. When I add them I get 13. So 8 times 5 is a way that multiplies to 40 and adds to 13. That's why our final factored form is going to be parentheses x plus 8, x plus 5. So the integers 8 and 5 have a product of 40 and a sum of 13. That's why we get to x plus 8, x plus 5. If we multiplied all these out, we'd get back to where we started. If a trinomial cannot be factored using only integers, it is called a prime polynomial, or more specifically, a prime trinomial. So I went out of my way not to give you these questions, I'm pretty sure, in Cengage. If you get to one that can't be factored, you would call it prime, and I believe that's included in the instructions. It's possible I have one in there that you have to say is prime, but I'm pretty sure that I tried not to pick those questions. Factoring trinomials in the form x squared plus bx plus c using grouping method. So we talked briefly about grouping method at the end of the last section. We're talking about it here. When we get to the next section, 6.3, it's pretty much the only method that we'll be able to use. So even if you don't prefer this and have another method you've learned that's working for you, just try and follow along with how I'm doing this. As always, if you've learned anything from seeing this material in a different setting, and it's something that's working for you and you're getting right answers, keep using whatever method's working for you. So here, we're going to be identifying a key number. The key number is C. So we start with this 15. We know that B, we're trying to get to 8, but we know that we're getting there using this 15. Specifically, what multiplies to 15 that would add to 8. So when we write out the ways to factor to 15, 1 times 15 does it, 3 times 5 does it, but 1 plus 15 would give me 16 when I'm looking for 8. 3 plus 5 is the way to get to 8. So what I can do once I know that it's 3 and 5 is I can break up the middle term. Instead of writing it as x squared plus 8x plus 15, I can write it as x squared plus 3x plus 5x plus 15. So I haven't mathematically changed anything. It used to be an 8x, now it's 3x plus 5x. 3x plus 5x would get me right back to 18 if I wanted, or to 8x if I wanted it to. But instead, what I want to see is that I can group these first two terms together, and I can group these last two terms together. If you properly split this middle term, you'll always get to something that will give you the factored form when you do factoring by grouping. So between the x squared and the 3x, I can take an x out of each of them and leave myself with x plus 3. Between the 5x and the 15, I can take a 5 out of each of them and also leave an x plus 3. Because x plus 3 is left behind both times, I know I've done factoring by grouping correctly. The final step is to do outsides times insides. Outsides, x plus 5, times insides, the repeated parentheses that I only write once, x plus 3. If I wanted to check that this worked, I could multiply it out, and I would get back to x squared plus 8x plus 15. So when you're using factoring by grouping, identify B, the things that the two factors will have to add to, and the key number C that the two factors multiply to. Find the two integers whose product is the key number and whose sum is B. Express the middle term bx as the sum or difference of two terms. Enter the two terms like this, where you're splitting that middle term that used to be there. Once you then factor by grouping and get a correct answer, you can always check it by multiplication. Be aware that these examples always use positives. They get a little trickier if you have a negative key number. If you get a negative C, that means it must be one positive and one negative number being multiplied, which means when you combine them, you're really subtracting. If I factor by grouping, again, this negative tells me that I'm going to multiply to negative 20 and that I'm going to subtract the two factors. So the factors of 20 could be 1 and 20, but when I subtract them, 20 minus 1 gives me 19, not an understood 1. It could be 2 times 10, but when I subtract them, 10 minus 2 gives me 8, not an understood 1. The last way to multiply to 20 is 4 times 5. When I subtract them, 5 minus 4 does give me 1. Specifically, it gives me a positive 1. So I need to be doing a positive 5 minus 4. That way, if I take positive 5 minus 4 and I multiply the two of them, 5 times negative 4 gives me negative 20, which means I'm getting to the right product. If I add them, 5 plus a negative 4 is really 5 minus 4, which gets me to the right sum, this positive 1. So, here we identify that 1 is the B, negative 20 is the C. We write the ways that we can multiply to negative 20. Either we can have positive 1 times negative 20, positive 20 times negative 1, positive 2 times negative 10, positive 10 times negative 2, or positive 4 times negative 5, positive 5 times negative 4. This shows what happens when I add each of them together. I'm looking for 1 as my B, so I select this combo of a positive 5 and a negative 4. That means that I can write that middle term that used to just be plus A as plus 5A minus 4A. If I have it expressed as plus 5a minus 4a, then I can see these first two terms grouped together, I can pull an a out of to leave a plus 5. These last two terms grouped together, I can pull a negative 4 out of to also leave a plus 5. Now that I have the same thing in parentheses, after pulling out the common factor, I can do outsides a minus 4 times insides a plus 5, which is the correct final factored form by the grouping method.